Good day to TenCon 2020, the panelists, organizers, and audience watching. My name is John Mark Bautista, and I'm here with Kel Kiwa and Dr. Usul Reyes. We are from the Ateneo de Manila University, and we are here to present to you our research titled Machine Learning for Remote Prenatal Care. So for a quick introduction, I would like first to define maternal death. Maternal death is the death of a woman while pregnant or within 42 days of termination of pregnancy, irrespective of the duration and site of the pregnancy, from any cause related to or aggravated by the pregnancy or its management, but not from accidental or incidental causes. Despite advances in health technology and decreases in cases, women are still dying from pregnancy-related causes that are in fact preventable. The World Health Organization estimates that more than 300,000 women died from pregnancy-related causes in 2015. So in the Philippines, the maternal mortality rate, or MMR, has decreased from 160 to 120 deaths per 100,000 live births in a span of 17 years. But if we compare that to other Southeast Asian countries, Philippines has been the top 5 countries with the highest MMR, with the lowest yearly decrease. And that is significantly high, especially considering that we are a middle income country. So what are the causes of the high MMR in the Philippines? Based on research, first is the lack of doctors, as doctors are more likely to migrate to rural areas or even abroad. Next is the lack of equipment and knowledge. Since doctors are inaccessible to urban areas, some communities rely on barangay health workers and they are challenged regarding knowledge, skills, and ability to deliver health services. Some other socioeconomic factors. As a woman with higher economic social class living in a rural area are more likely to receive complete care. With all these anomalies, we propose to solve some of the problems in our health sector. Telemedicine with predictive system for prenatal care. As we are optimistic with its potential and possible impact it could bring in our health sector. So some definition of terms. Telemedicine is an integration of wired and wireless transmission of medical data where biological signals, images, and videos are transmitted to remote locations of diagnosis. Machine learning, or ML, algorithms have been the basis for data mining frameworks for detecting patterns in large datasets. Prenatal care, or PNC, is the use of healthcare during pregnancy that aims to screen for health conditions that are likely to increase the possibility of adverse pregnancy outcomes. So some previous studies that we base. One previous study proposed a system for an IoT, or Internet of Things, cloud architecture which has data acquisition, data transmission method, database, analytic system, and a visualization system. Another study conducted by the IEEE to determine and monitor probabilities of abnormalities in the first trimester of pregnancy using machine learning. And lastly, a recommendation by the expert panel on the content of prenatal care in 1989 showed that prenatal care visit schedules should be flexible based on the differences in situations of each expectant mother. So we're looking at one of the applications or potential applications of this system. Here are some of the previous studies that have used machine learning ML in prenatal care. This table includes their method, data size, and accuracy. One particular study we are focusing on is that from Macbulut, as we would later compare this study with our own. So some advantage. This system could lessen the pressure on doctors or health personnel and cover the problem of distance. It could encourage and promote quality health practices in rural areas and increase instances of prenatal monitoring. And lastly, the availability of data sets could aid the possibility of more services that are community-focused, personalized, in tackling health problems. In this study, our main objectives are develop a mobile application where the user can input and view vital data. Next, choose the algorithm that is efficient based on their performance parameters. So in our methodology, here's our simplified system diagram. It contains the smartphone of the patient that would be used for the data acquisition, where the patient information would be inputted. The internet or Wi-Fi connection would be used to connect it to the cloud database where the data is stored. The prediction system or prediction algorithm gets the data from the cloud database, processes it, and returns that output. The output would then be shown to the Android devices where the doctors can see. So here's a glimpse of our mobile interface. On the left is the home page where the patients can have a maximum of 4 visits where they can input data. On the right is the patient information which will be processed by the prediction system. The goal of the machine learning system is to predict whether the fetal health status is normal or abnormal given the maternal history data. The output would be N for normal or negative cases and P for positive or abnormal cases. So the steps for the machine learning system includes preparation of the dataset, choosing the machine learning algorithm, training and testing of the dataset, and evaluation of the algorithm. The dataset would be used to train the algorithm. It is acquired with permission from Makbulut and contains data from 97 fetuses and has 23 features. Of the 23 features, only 9 will be used. The dataset is divided according to data type, numerical and categorical. The 4 algorithms to be compared are decision tree, random forest decision tree, k-nearest neighbor, and the support vector machine. For the training and testing sessions, the dataset was split. Out of the 97, 20 of the data would be chosen randomly for the testing session, and the rest would be for the training sessions. Tuning of the hyperparameters was done after each evaluation of the test sessions to optimize the performance of the algorithms. So the performance parameters to evaluate these algorithms are accuracy for the training and testing sessions, precision for the NNP class, recall also for the NNP class, F1 score for the NNP class. So moving on to the results and discussion. The algorithm with the highest scoring training and testing score is the random decision tree. It's the highest accuracy, which had a 0.987 and 0.9 in the training and testing sessions respectively. The random forest decision tree also had the highest performance in precision, recall, and F1 score. And at this point, it was determined that the random forest decision tree is the best algorithm to use out of the 4. Lastly, when we compare our study to that of Akbulut's, our study had a slightly better performance, especially when compared to its precision. We had a 0.005 higher score in its accuracy, 0.19 difference in its precision, no difference in recall, and 0.05 difference in F1 score. So here's the screenshot of our system when the data has been inputted. As you can see, the status is none when the data has not been processed yet. In this case, the status has been pure N after it has been processed. And we also added data that will not be processed during prediction but could be relevant for diagnosis, such as disabled relatives, disabled children, or the presence of diabetes. So in conclusion, telemedicine has increasingly been explored to continually monitor patients without doctors, and diagnosis could become more reliable with the aid of analytics. With the development of machine learning, it could further aid its accuracy and reliability to help doctors, especially in countries like the Philippines, in their diagnosis and to determine which approach to proceed for patients. Thank you for listening.